Our focus is making clean water, and it's really not in generating power. So that's not our area of expertise. So what was attractive for us is we can get back to treating water and let the power experts focus on the power generation aspect of it. The name is Guy Mecabe, and I'm the Industrial Automation Manager for the City of Orlando's Water Reclamation Division.
Thanks, Guy. I really appreciate you taking the time to meet with me and talk with me today. So, what I always like to start with is, how is it that you describe what it is that you do?
I run a group known as the Industrial Automation Group, and we're essentially responsible for everything necessary to fully automate wastewater treatment processes. Automation is kind of defined as the application of technology, programs, robotics, or processes to achieve outcomes with minimum human input. So the group is comprised of two different sections. We have a specialty electric team and a systems team, which is rare for a municipality to have an organization like that in-house, but it allows us to do all of our automation needs in-house without farming them out to contractors.
It's excellent. So, what sort of projects is the Industrial Automation Group working on?
With the programming specifically, we do all of our own programming in-house. So when we have a capital improvement project, all of the electrical, all of the mechanical devices are all installed. But then it'll take us maybe a 4-week period to do all of the automation programming for that entire process area. So we have 3 of those ongoing right now.
Excellent. Okay, so when we're thinking about the footprint of the Orlando Water Department, how many treatment plants are you all servicing? And as far as the water treatment, the service area goes, how many people are you all ultimately servicing at the end?
Yeah, so the Water Reclamation Division is one of 5 divisions within Public Works. And I want to make sure it's not confused with drinking water. The process of treating raw sewage is a much more complicated biological process. But we have about 250 employees in the division, and we have 3 water reclamation facilities. We have Water Conserve 1, Water Conserve 2, and Iron Bridge. And then additionally, we have 240 pump stations throughout the city. We have the Orlando Wetlands, which is a first of its kind, large scale man made wetland used to treat reclaimed water. And the underground piping, we have about 800 miles of underground piping, which is about enough to reach from Orlando to Washington, D.C., if stretched straight out. And I believe we service about 400,000 people right now.
Wow, and that's great. Very, very impressive. And so, one of the reasons that we're chatting here today, as you mentioned, the 3 treatment facilities, and specifically, we were connected over Iron Bridge. And so, I want to chat a little bit about the project at Iron Bridge and kind of what led you all to start with evaluating the backup energy system there.
Yeah, so the original design for the backup power system here it was originally installed in 2007, and it was more focused on features than maintainability. System was over automated. And too many of the features were put inside of a PLC rather than using actually industry standard devices to perform those functions. So it became a very complex automated system. We also installed 2.8 megawatt 1247 generators as opposed to several smaller 480 volt generators. So maintaining those larger generators is certainly a burden. So we also have to deal with single service providers because proprietary software, and then the maintenance costs just became outrageous. So that led us to start looking and seeing what options were out there.
That makes a ton of sense. What would you all say is what was the most pressing issue that your old department kind of was facing as you entered into this evaluation?
Yeah, so the most pressing thing for us is knowledge transfer. We have a kind of an aging staff, and we're also in sort of a technical tradesman drought. So it's very difficult to find new electricians to come in and sort of take the reins from the older guys. So as they retire out, we're going to be left with this really complex system that nobody really knows how to operate. So that's been a real issue for us as we look for a new system.
Yeah, makes a ton of sense. Let's talk a little bit. You touched on this a little bit about Iron Bridge itself, about the system being installed in 2007, but let's get a little bit of background there as far as kind of the age of the facility. Like I said, you mentioned that the system was built in 2007. So kind of talk about the age of your existing system, and then if you had any sort of breakdowns or maintenance concerns beyond just kind of the knowledge transfer piece that you all were contending with.
Phase one of Iron Bridge came online in 1982, and then that was quickly followed up by phase two in 1989, and phase three in 1991 when the plant was fully commissioned. So it's been around for quite a long time. Many of the systems that we have been upgraded, so there's very little that's still original. The medium voltage and the generators, power distribution, that was all replaced in 2007. And then our 480 volt infrastructure was replaced in 2021. So we're really electrically down to just anything below 480, and we replace that as needed. There's always something to fix at Iron Bridge. It's such a complex system, so there's so many moving parts, and we operate 24/7, 365, never shut down. So that adds to the burden. A normal factory, when production goes down, you lose money or revenues. With a wastewater treatment plant, when you go down, it becomes an environmental public health risk. So that leads to a lot of the repairs being completed as an emergency, which also adds to the cost of it.
That's excellent. So would you say when we talk about the need for the the project happening at Iron Bridge, would you say there was a particular singular incident or anything like that that came up, or was it just kind of you all were aware of the age of the backup system that was in place and just knew that end of life was near?
Yeah, definitely the latter. With a system that's built on hardware and software, we know that those things don't last for 30 or 40 years anymore. So there comes a point in time where things are outdated and they just need to be replaced. We try to take more of a proactive stance with maintenance rather than reactive. So with it aging, and we know that it's aging, we want to go ahead and take steps to get it replaced. So many of the components used in the system are no longer manufactured, and we're finding ourselves now looking for surplus or refurbished equipment as well. So that definitely lends to the fact that it's time to replace it.
Yeah, that's a huge problem. If you can't get the parts for it, there's nothing you can really do. How about so you all are everything is automated in house now. How are you all managing that backup generator system? Well, I say now, the project itself is I think it's commencing or it's starting to be installed. But so how are you all managing the system that's in place now?
As I mentioned, everything's very automated. So we have both an open transition for when power is lost unexpectedly and a closed transition for seamless transfer prior to storms or any known impacts that we know. Our operations staff basically has a single button that they press from our SCADA system that will bring the generators online, synchronize them with utility, and then perform any load sharing functions. And then the process is the same coming off. So operating the system is not a problem. The maintenance is more of a problem than anything else. But my team manages the maintenance, but we also use contracted service providers who are manufacturer recommended or licensed to provide service for that. So we're very dependent on those.
Yeah, excellent. So let's talk about the new system. What was it that you all were seeking with the new backup power system that you put in place?
Definitely a more industry standard system that's easier for us to maintain, easier for service providers to recognize. Our current system, as I mentioned, was very custom. So we had a lot of training in house for our technicians, but in addition, the service providers that would come out, they'd never seen a system like this before. So it took them time to learn it. We didn't have really highly skilled service providers for it. So we're definitely looking for something more industry standard. Um, our switch gear is excellent. We're happy with that, and we prefer to be responsible for that. But it's the generators themselves that we're looking to sort of shed.
Yeah, so you all had a really interesting and kind of bespoke solution there with your switchgear in house. Can you explain to me a little bit why that was a concern?
Why the switch gear was a concern?
Not a concern. Let me rephrase that. More why you all wanted to maintain that in house.
Yeah. So we have a lot of flexibility with the switch gear. We have the ability to switch different sections of the plant around. We have a lot of built-in redundancies into the switchgear. So just from a maintenance aspect alone for electrical PMs and that, we're able to do that switching and perform the maintenance that we need. So we didn't really want to give up that flexibility to a third party.
That makes a ton of sense. So then that segues me into why did the Water Reclamation Department ultimately choose to work with Duke Energy One on this?
So we did a lot of research, and reputation speaks for itself. Every time we spoke to the project management team at Duke Energy One, we gained more trust as a result of their confidence and experience. So we really gave them a tough interview. We also wanted to see the system in action and talk to customers who have used the system. And Duke Energy One welcomed that approach. They were very transparent.
Yeah, I love to hear that. Um, we talked a little bit previously about kind of the model that Duke Energy One offers, and kind of the way that this is being put in as far as the power as a service model, or power and electrical infrastructure as a service, what however we want to call it. Sometimes uh, we call it backup power as a service, whatever your phrase du jour is. Um, what was it that you liked about that model?
So the power as a service for us really means just hands off. For us, it's almost as if we have two utility power feeds. It's before our infrastructure. So um, we still have the same level of redundancy, but now we have experts who are solely focused on the maintenance of emergency power generation equipment, maintaining that. Our focus is making clean water, and it's really not in generating power. So that's not our area of expertise. So what was attractive for us is we can get back to treating water and let the power experts focus on the power generation aspect of it.
Yeah, I love that. What do you think ultimately, kind of zooming out, and as far as other municipalities, what do you think they stand to gain from kind of utilizing this same, infrastructure as a service model if they've got similar projects?
Yeah, I think just like I said, maintaining water is our primary objective, and I think that they're going to see the same. I think anytime that they can get back to doing what it is that they do and not having to worry about the power and the generators and things that they're not familiar with, I think they're going to leap at the opportunity.
Sure, love to hear that. And you've touched on this a couple of different times, but why is it that maintenance and kind of that service, once the project itself is installed, why do you think that is such a consideration for groups like yours? And you've kind of touched on it a couple times here, even as we've talked about it.
Yeah, so there's so many different systems made by so many different manufacturers that our employees can't possibly know it all. And having a trusted partnership is crucial to any successful organization. The plant really never sleeps. The equipment needs to last and perform for the entire life cycle, and a lack of maintenance is not going to allow that to happen. So, as I said before, our goal with maintenance is to be proactive and not reactive, and proper maintenance is the key to that.
Brilliant. I appreciate it. So let me make sure I'm clear too. So I believe the project itself, that with the new system, is it in installation right now? When is it set to be completed?
So our switchgear is set to be delivered in August. All
Okay.
of the concrete pads have been formed. All of the conduit is in place. And then between August and I believe it's November, we'll be waiting on the power blocks, the generators themselves. So we anticipate a startup probably in January 2026.
Excellent. Guy, I really, really appreciate your time here today chatting with me. And uh, thanks so much.
Absolutely. Thank you.